Hi there, this is Yanis from the Arcweave team, continuing with this tutorial on the Arcweave plugin for the Unreal Engine. In this episode, we will download and play with an example project that demonstrates the power of integration between Arcweave and Unreal. As we will see, we can make arrangements so that the game writers and designers can influence the packaged game from inside Arcweave without using the Unreal editor and certainly without recompiling a build. First, we go to the repository of the example project on GitHub. We can find the link in this video's description, as well as the Arcweave documentation page on game engine integrations. We go to the code button and download as zip. When this finishes, we go to the downloads folder and extract the zip file. In the contents, we have all the necessary files for the example project. So let's generate Visual Studio project files. This project is made in Unreal Engine version 5.3, so we need this version or later to open it. When we're done with generating the Visual Studio project files, we open the Arcweave demo SLN file in our IDE and build. Once it's done processing the files with success, we can start the example project in the Unreal editor. Our project now is open and we can check out the scene and all the files. In the plugins folder, we can find the Arcweave plugin already installed and running. Now let's connect our Arcweave project with the Unreal editor. As we've said in the previous episodes, we need to get the hash of the project and the API token of the project's owner. To make sure that everything is connected properly, we'll need to fetch the data and see for ourselves. In this example, when we press play, the data will be fetched for the first time. And let's see if they properly came through. So we click play and we see that this panel here gets populated with the variables of our project. In this example, we're not showing boards and components anymore, just the story variables. Let's now explain in detail how this scene and the Arcweave project actually connect with each other. The scene is one contained level. It has an environment with various lights and a particle effect for rain. It also has our player and two NPCs with whom we can interact. And finally, it has a simple HUD element. If we press play, we see there is a gear icon that opens our settings menu. Opening this, we see the API token and the project hash that we've pasted from our Arcweave environment into the Unreal Editor's project settings. As I said in the previous episodes, we can actually change these dynamically from within our play if we need to access a different version of the Arcweave project, and we can do that without recompiling. More on that later. At the top right corner, there is a fetch button, and if we press that, we fetch the data from our Arcweave project, and then we get a message, hopefully, telling us that the data has been fetched correctly. At the bottom left corner, we have this panel with the story variables, the global variables of the Arcweave project. Just to double check, in our project we open our global variables. We can see that they are the health of the healer, Wanda's health, and have potion. And it's the same as we see in our Unreal editor. To study the logic of the HUD and how we set up the dynamic fetching and the variable display, we can do that in a class called HUD New Class, which we can find under Widgets, and it's right here, HUD New Blueprint class. This is where we can see in detail how we've set up the whole HUD and also how our story's logic gets translated in blueprint format. The most complicated logic of the project is actually the dialogue system. Everything else is pretty straightforward. Let's now see how we've set up the NPCs. If we select a character and press Ctrl E, we open the character's blueprint. The NPCs are base character class in Unreal Engine, and they're already set up with their animations and collisions. To demonstrate how we can influence game elements from inside Arcweave, we'll see how we can change a character's name, their sprite's color, and their health score. If we click on any NPC, we see 3 fields under their config category: Dialog Board ID, Component ID, and Health Variable ID. Going to the character blueprint, we see all 3 of these are public variables. But what do they actually represent regarding the Arcweave project? In our Arcweave project, we see that every character is represented by a component. Something that is not so obvious is that every Arcweave object, boards, elements, components, branches, variables, etc., everything has their own unique ID. Therefore, every character component has its own ID, every character health score has its own ID, and the same with the board of the character's dialogue. And this is how we've connected each of these Arcweave objects with the Unreal Engine. We provided each character with its component's ID, as well as the ID of the board where their dialogue exists, and the ID of the variable representing their health score. A disclaimer here, this is certainly not the only way we could have done this. For example, you can have a look at our demo for the Godot plugin and see a different approach. Also, stay tuned, we'll soon make a video exploring different ways you can connect Arcweave objects with your game engine of choice, and you can certainly improvise your own solutions. So back to this solution, how do we get these IDs? They're not available in the project itself. Well, they are in a way, because we can find them in the project's JSON file. So to get that, we need to go to Share and Export as JSON. We don't need the assets, and then export. So we save the JSON file and then open it in our editor. Familiarizing ourselves a bit with the Arcweave JSON file is actually not a terrible idea. You can find all of Arcweave's objects here: elements, components, connections, branches, conditions, variables, jumpers. Everything is here with their ID, their name if they have one, their target element, etc. Making sure we're under components, we look for the component with the name of Wanda. All the Arcweave objects appear as dictionaries, and the main key is actually the component ID. And this is where we get the ID for our component, and we paste it inside the Unreal editor at the config of the character of Wanda or the healer, etc., etc. In the same manner, in the JSON, we search for the board name Wanda Dialogue and get its ID. And the same with the health variable. So this is the way we connect each character of the project, their dialogue, and their health score. Another example of controlling the Unreal Engine characters from within Arcweave is to use the component's attributes, for example, a text attribute like color and the image cover. If we press play, we can demonstrate. When we hover over this NPC, we can see he's the healer. We get his name, the sprite has a specific color, and the score of the health. All these come from the Arcweave project. While still in play, now if we go to the healer component in Arcweave, we can actually change the name, for example, healer number 2, and color from green to red. And back to the game engine, we can click Fetch, and we see that the game data gets refreshed. How this works is that we have mapped specific color values with predefined strings, and if the strings from the component match, then we can assign the color to the character sprite. Let's continue with the NPC setup. When we run the project and approach an NPC, we can click on them and start the dialogue system. This is set in the Arcweave project for each character. But how does the game engine know where to start? What is the starting element of each dialogue? First of all, let's go to our starting board. We can see that the starting element, called Play Mode Start, is not something we actually want to use in our game. It is here because we want to test this project in the Arcweave Play Mode as well. If we press play, this is where the play mode begins in this starting element, and we can choose which dialogue to play first. So let's go to Wanda first, and we can choose Hang On, I'll be back for help to finish the dialogue. And eventually we get back to our starting element. This is because this is the structure of Wanda's dialogue tree. From the starting element of the project, we go to the start of Wanda's dialogue, and this is where the actual dialogue begins for us. This is the element we want to render in the game engine. And the dialogue continues, we go to the hang on response, and it eventually leads us back to the project's starting element. So this works in the play mode where everything is part of one unified story flow, but how will the game engine know where each dialogue begins, where it ends, and which elements it's supposed to render? In this example, we don't want to render this play mode start element at all in our Unreal game. There are a couple of ways to let the game engine know. In this specific video, we will demonstrate one of them, which is to use element attributes. In order to tell the game engine where each dialogue begins, we've assigned an appropriate attribute to the first element of each dialogue. So if we go to the first element of our dialogue with Wanda and hover over this icon here, it tells us that this element has an attribute called tag. If we double-click this icon, we open the element properties and we can view and edit our attributes. We see that the tag attribute has the value dialogue start. Don't be confused. The tag attribute is a custom one that we just made up. You can call it whatever you like as long as it corresponds to the settings in your Unreal editor. The same thing we've done with the last elements of every dialogue. We can see that Wanda's dialogue has 1, 2, 3, 4 elements that end the dialogue and then send us back to the play mode start. And we notice that again, all these elements have this icon, which if we hover over, it tells us again there is a tag attribute, which this time has the value of dialogue end. Therefore, whenever our game must start a dialogue, it will look for the relevant element that has the attribute tag with value dialogue start, while if it comes across an element with the tag of dialogue end, it will stop following the flow. A different way we could have done this is to attach specific components for starting and ending the dialogue. We've done this in the Godot plugin demo, feel free to check it out, and this is where we're using these two elements called Wanda starting element and Healer starting element. Back to the game, we see the dialogue UI has the character's avatar, his name, and the dialogue lines, as well as option buttons underneath. All this information comes, of course, from the Arcweave project and gets refreshed every time we click the Fetch button. When it comes to handling the storytelling and the dialogue, in the demo, we've imitated the logic of Arcweave's play mode. This logic we can see in the DialogueScreen class. That's a widget class that is under Arcweave Demo Widgets folder. Here we can see in detail how the play mode's logic is mirrored inside the Unreal Engine. The most complicated part of this blueprint is the evaluation of ArcScript, Arcweave's scripting language, which may exist in branches, elements, and connection labels in our Arcweave project. This happens in special transpilation nodes like this one here. This is how the Unreal Engine checks the state of the global variables and evaluates the conditions. Other than this part, everything else is pretty straightforward. So far we saw how we can influence the game characters. Now let's give an example that actually influences the rest of the game world. We have created a component called environment, and if we open this, we see it has two text attributes, time and weather. And we can see the possible values these two attributes can get. So time can be either day or night, and weather is either clear or rain. At the same time, in the Unreal Engine, we've done the appropriate arrangements for a night scene to get activated whenever the environment component says so. So if we change the day to night and fetch, we get a night scene. In the same way, if we change the weather from clear to rain, of course, after fetching, it will start raining. There are other ways we could do something like that. We could use element properties, global variables, component attachments to signify as the story progresses that we could change the time of day or the weather in different scenes. Let's have a look at how these two effects are handled. Under the folder top-down maps, we see two maps, day and night. What we do here, we have an environment manager in each level. This is in Arcweave Demo Blueprints Actors folder. And when we open it, we see that on the fetch, we pass the data and change our level for day to night. And for the rain, we switch on and off our particle effect. The whole point of this on-the-fly fetching of story data is to allow a workflow in which our writers and story designers don't have to use the Unreal Editor, and this is tremendously helpful for both ends. We only have to make sure that each Arcweave object connects properly to our game object in Unreal. Then we can package the Unreal project, give the executable file to the writers, and they can continue writing and editing the story, fetching the updates on the fly, and testing it in the form that it will eventually be shipped. Such a workflow can be liberating for both the writers and the developers. So first, let's see how we can package the project. If we go to Platforms, Windows, Shipping, and Package Project, we choose a folder, and then we begin the packaging. When when we're finished, let's go to our package folder and run the exe file. Now the same things are going on as in the editor. We have the settings, the fetch button, and the global variables. So first, let's see how we can dynamically change the project hash and the web API. If we go to the gear icon for the settings, we can paste any hash we want, and this is actually a very easy way to test various project versions. We have our various projects in Arcweave with their own hash, and we can easily just swap the hashes of each version and try the different versions without much difficulty. To demonstrate this, we actually have two versions already. The one has the healer's health is 30, and the other one is 50. Also, we make sure that the weather and the time of the day is different. So in one version we get night and rain, and the other one is day and clear sky. So if we go to the first demo and take the project hash and paste it, we click save, and this means we save the current token and hash in our drive, in our local drive, so the next time we run the exe file, it will load them again. So now if I refresh, I get the values from demo 1, the first version of the project. And it's a rainy night. This is great power in the hands of the writer and the designer who can modify game elements without even going near the game engine. We can do other things like change the name and color of Wanda. Let's change the name to Wanda Landor Elf. Okay. Yeah, why not? And the color to blue. And then we can fetch. And here it is. All these are but examples of ways that we can affect the game without actually using the Unreal Editor. We can work from inside the Arcweave. All we need is a packaged build developed and connected by the Unreal developers, and then the designer team, the writers, can make decisions without interfering with the game engine itself. Now let's see how we can adjust our workflow to work with Arcweave data. The way our story goes is Wanda is wounded and we need to get her a healing potion. So we have to go to the healer, and then take the potion back to Wanda, and this increases her health by 60 points. But let's say that we decide to change the actual health points that she gains by drinking the potion, so what we need to do is go to our Arcweave board, find the point where this change happens, where this variable gets assigned, and modified with any value we want, and then fetch. We go to the healer again, and then take Wanda the potion, and we see that her health is now raised by 50 points. So this was an example of how we can actually modify the data in Arcweave to influence how the game behaves. The great benefit of this is that our writing and design team can work independently from the Unreal developers. Once the team connects the Arcweave story objects with their Unreal counterparts, then we can easily update the story and see the results in the packaged game on runtime. That was all for this tutorial on Arcweave's integration with the Unreal Game Engine. If you're finding these tutorials helpful, please subscribe to Arcweave's official YouTube channel. You can find us, the Arcweave team, hanging out on our Discord server, and of course you can follow Arcweave on Twitter, Facebook, and LinkedIn. I'm Yanis from Arcweave. Thank you for watching, and let the games begin.